This is a course on software engineering, and this is based on the book Fundamentals of Software Engineering by Dr. Rajib Mal, and he is eminent, famous person, a professor from IT Kharagpur, and he has done a great work in this field. And his book is world renowned. Most of colleges and universities in India, they follow this book, and we will be concentrating upon his content, and we will be covering these PPT. Again, this PPT source is from Dr. Rajimal only. So what we are going to do is to cover the various chapters and then try to answer or give you a hint about the questions of each chapter. So organization of this particular session is: what is software engineering, difference between programs and software products, because this is often asked, what is the difference between a program and a software. Then some discussion on evolution of software engineering, then notable changes in from the earlier times to now till now software development practices, and then introduction to life cycle models, followed by summary. This is an often asked question: what is software engineering? So we have various definitions on this, and as we move on, the innovations and past experiences towards writing good quality programs cost effectively have contributed to the emergence of software engineering as a discipline, as a separate field. So software engineering is an engineering approach to develop software, like building construction analogy. Like if we try to build, construct a building, so there are certain steps involved. There is a whole engineering behind it. Software engineering is like that only. It is an engineering approach to develop softwares. And you can also say that it is a systematic collection of past experiences, techniques, methodologies, and guidelines. So software engineering discusses systematic and cost-effective techniques for software development, and these techniques help develop software using an engineering approach. What about engineering practice? We have heavy use of this past experience, what people have done, and this past experience is then systematically arranged, and then also theoretical basis and quantitative techniques, they are already there, they are developing, and some of them, they are just thumb rules, but we have different alternatives also, possibilities also, so there has to be a trade-off between these alternatives. And also, as I just suggested, it is a pragmatic approach to cost effectiveness. We want our software to be built in time, before schedule, and also it should be cost beneficial. Like in this particular example, or this chart, this is actually an evolution of technology with time chart. This is technology, and this is time. So we have art, then it became, this software engineering was an art. In this case, it shows an growth, which is historic past experience. Then this is organized use of past experience. Then it became craft. This plateau you see is craft. And then it again increased with time, gradually, which shows systematic use of past experiences also, in addition with scientific basis. And now we are in the times where we call it as engineering. So in a build and fix style, a program is quickly developed without making any specification, plan, or design. So the different imperfections that are subsequently noticed, they are fixed. This was previous approach, and now we have come to this approach. So why we should study software engineering? This is an often asked question also. First of all, to acquire skills so that we are able to develop large programs. And the complexity has increased exponentially. Yes, it has grown. And as the requirements have increased, the difficulty level has also emancipated. So the ad hoc approach breaks down when the size of software increases. The ad hoc approach which we just saw here, these approaches, they do not work. So one thorn of experiences is worth a whole wilderness of warning. I hope you understand what I am trying to speak. Then not only this are the software products becoming progressively more expensive than hardware, They also present a host of other problems to the customers, like software products are difficult to alter, debug, and enhance, and use resources non-optimally. They often fail to meet the user requirement, as far from being reliable, frequently crash, and are often delivered late. So why do we study? Because ability to solve complex programming problems and how to break large projects into smaller and then erstwhile manageable. And as I just suggested, you need to know the techniques of creating specification, design, interface development, testing, project management, and so on and so forth. Then to acquire skills to be a better programmer, software person. You can produce higher, and then also the quality of the programs would be better. Then we come to software crisis. What is software crisis? Because software crisis, what is the crisis? The word is quite hard and harsh. Software products, they often fail to meet user requirements. They crash, they're expensive, difficult to alter, debug, and enhance, delivered late, and use resources non-optimally. This is a chart or a graph. These are hardware and software cost. You can very well witness that in 1960 it was in this range, and with year it has gone down. It has reached somewhere here. This is because of your software engineering. There are various factors which contribute to the word called software crisis. We have larger problems. We don't have adequate training in software engineering, and this is shorting. Is the skill is relatively going down, and then low productivity improvements. These are all the factors which are contributing to our software crisis. Then there are certain questions which need to be answered, like what is a program or a software products. So let us see them in just a few bits. Programs usually small in size, while software products are large. Programs authorize himself or himself authorize is to him that he's a sole user. And for software products, we may have large number of users. Single developer for a program, maybe more than that. We don't know, but we categorize program for single developer, while team of developers are involved in a software product, making a software product. Programs, they lack proper user interface, while this is products are well designed interface. Lack of documentation or no documentation in programs, while a software product should be well documented, and often this should contain the user manual, which is an important part. The ad hoc development in case of programs, while there is a policy or a process of systematic development as far as software products are concerned. So these in this way we can categorize these two. We have computer systems engineering. What is computer systems engineering? It encompasses, or it imbibes in the software engineering. And many products, they require development of software as well as along with them some hardware to run, like a coffee vending machine, say a mobile communication product, etc. So we have a high level program going up to deciding which tasks are to be solved by software and which ones by the hardware. So we have to create a specific distinction between these two. So what happens? Hardware and software, they are developed together. Hardware simulator is used during our software development only, and then we integrate hardware and software. We combine them, and then we perform system level testing on this. So as far as computer system engineering is concerned, we have a feasibility study, then requirements analysis, and then specification, then hardware software partitioning, which give rise to hardware development in separate session and software development. Then we combine them, and then finally we perform integration and some sort of testing, which is we call as project management. So how it happened, what we are talking, how it has taken place. So early computer programming in 1950s, programs were being written in assembly language. Programs were limited to about a few hundreds of lines of assembly code. Then every programmer developed his own style of writing programs, like according to his intuition, or we call it as exploratory programming. According to one's intuition is exploratory style of software development. And there are things which are wrong with exploratory style of software development. Then came high level languages such as Fortran, Algol, COBOL. They were introduced. and they reduce software development efforts, immensely. Then software development style was still exploratory, means typical program sizes were limited to few thousands of line of source code, LOC we call it. Then we had control flow based design in late 60s. The size and complexity of program they increased further. That means exploratory programming style, they were insufficient, and then programmers they found they found it very difficult to write cost effective and correct programs, both of them. They also found that programs which are written by others were quite difficult or sometimes impossible to understand and then to maintain. To address this problem, these programmers they advised pay particular attention to the design of the program's control structure. Here comes the design. So programmers control structure they were indicating the stepwise or the sequence in which the program's instructions they are sought to be or expected to be executed, and also to help design programs having good control structure. And then something was developed, we call it as flow charting technique. Again, in this is all happening in late 60s using flow chart techniques. So one can represent and design a program control structure now. They have a proper formation, some structure, and one understands a program just by mentally simulating the program's execution sequence step by step. And a program having a messy flow chart or not well organized, unorganized flow chart representation, they are consequently difficult to understand and debug. So it was observed these go-to statements make your control structure quite difficult and messy. Go-to statement alter the flow of control arbitrarily. There is no control, you cannot go in a sequence, it just changes from one point to another. So there was a need to restrict this go-to statement, and it was quite recognized there. So many programmers had extensively used assembly languages while they were developing earlier on. So these jump instructions are frequently used for program branching in assembly languages. The program considered use of go-to statements, they were inevitable. How to get rid of it? Then at these times, Dijkstra, he published his article, Go-to Statement Considered Harmful. And many programmers, they were unhappy. Like today in software testing, there are various options like, or you can say standard, like SJF is there. Then these are so restrictive. Now programmers, they are holding their nerves and they work upon it. If they want a good program, they have to work on it. So they published several counter articles for Dijkstra, countering Dijkstra, highlighting the advantages and inevitability of go-to statements. They tried, everything that could be possible. But it was conclusively proved that only three programming constructs are sufficient to express any programming logic, any programming construct. First is your sequence, then selection, if else, and then iteration, like while, for, do while. Only three are enough. You don't require these constructs which are making a program clumsy. Then everyone came to the conclusion that it is possible to solve any programming problem without using go-to statements. And they formed the basis of structured programming methodology. Here came the structured programming methodology. The program is called structured. Why? When it uses only these structures or these constructs, sequence, selection, and iteration, which I just showed you. So as the advent of structured programs, unstructured control flows were highly avoided, and they only consist of neat set of modules. Only we have functions, modules, procedures, and they use single entry and single exit program constructs. So these programs, which we call as structured programs, violation to this structure they are permitted due to some practical considerations, such as you want to premature exit, you want to exit prematurely from a loop, and you want to do some exception handling also. In this case, you can do it. Then these structured programs are quite easy to understand, read, maintain, and quite effort are highly reduced along with the time for development. Then research experience shows programmers they commit less number of errors while using structure like if then else and do while statements, and this compared to test and branch construct also. And then it was discovered that it is important to pay more attention and to concentrate to the design of data structure of a program, and then to design of its control structure. And in this all is happening in early 70s. And techniques which emphasize designing the data structure, like deriving program structure from it, and we call them as data structure oriented design techniques. Let us have an example, like JSP, that is Jackson's structured programming methodology came. It was developed by Michael Jackson in 1970s, not the dancer. And then data structure oriented design, which we call as JSP, Jackson structured programming methodology. The program's code structure should correspond to the data structure. It became important. And in this JSP methodology, a program's data structure are first designed using notation for, say, sequence, selection, and iteration. And then the data structure design is used to derive the program structure now. Several other data structure oriented methodology also they came into existence, like Warnier or method. We have come up to data flow oriented design. So in late 70s, what happened now? These data flow oriented techniques, they have come up and they educated that the data items input to a system, they must first be identified or known. Then processing which is required on these data items, which is employed to produce our output, they need to be identified as well or determined. So what this data flow technique it identifies? First of all, different processing stations or functions in a system. Going again back to this modular form. And the data or the items that are flowing between these processing stations. So we have processing stations and data flowing in between. The data flow technique again is a technique, we call it as a generic technique. We may employ it to use or to model the working of any system. Not just it is confined to software systems, but to other systems as well. And the most important thing about this data flow technique or techniques are their simplicity. Just for an instance, let us take an example of car assembly unit. This is a data flow technique. We have an engine store, a chassis store. Then we fit the engine. Then now we have a chassis with the engine, right? Then from the door store we take door and we fit the doors. Then we partly assemble the car. This is the partly assembled car. Then we again go back to access. From wheels store the wheels and we fit the wheels. And the assembled car is then painted and tested. Right? This is a car assembly unit. There are certain things which are happening here also, but we have just tried to delineate this car assembly from that. So just by this data flow diagram, it has become so easy and so intuitive to understand what is going to happen and how can we implement this car assembly unit in a software or a program, right? Then in 80s, it was an era of some revolutionary thing, that is object-oriented design. So we have object-oriented technique, which is what we think as a design approach. So natural objects or objects which can be which are live or they exist in our society, in our life, like employees, payroll register, etc. And they have found their place for the first time and they were first to be identified. Then these objects, they have some relationship. So why not to talk about their relationship, such as their composition, their reference, inheritance between two objects or number of objects. They were found. And each object, they act on some data. So we need to have some data which should be hidden or data abstraction of an entity. It gained a wide acceptance because of its simplicity, reusability, and the time and cost they have lowered. The code could be more robust now, and maintainability has increased. It was easy to maintain. So what it happened, the way we discussed, the codes was like this. First it was ad hoc, exploratory, then it came down to control flow based, then data structure based, then data flow based, and finally object oriented. Now most programming languages, they are object oriented, or in some or the other manner they adopt this paradigm, object oriented paradigm. But there are other software techniques or software engineering techniques also. They were involved. The improvements to these software design methodologies, they are very conspicuous. Like in addition to the software design technique, other techniques were also by the side. They were also gearing up, like life cycle models, specification techniques, project management techniques, testing techniques, debugging techniques, and quality assurance techniques, software measurement also techniques, and then case tools. All of these bullets or headings which we are going to discuss in this course later on. So, what was exactly the difference between exploratory style and this modern style, what we are using, modern software development practices? Use of life cycle models. Now we use life cycle models. There are various stages, well thought, well planned, various stages of software development. Like we start with requirement analysis and design, then go to specification first and then design, then going to coding. So this takes a very less effort and part if these two are defined and worked or emphasized. Then once things are ready, testing is to be carried out. So emphasis has shifted from error correction to error prevention. We became more proactive rather than being reactive. So modern practices, they emphasize this detection of errors as close to their point of introduction as possible. If the software has some vulnerability, then that is checked beforehand. While in exploratory style, errors are detected only during testing, not before testing. But now focus has shifted on finding many errors as possible in all the stages of development, each phases of development. In the previous style, the coding is synonymous with our program development, but now coding is considered only a small part of program development effort. As I just indicated, it takes least effort if other efforts are done properly, are made properly. The efforts and attentions have now shifted more to requirement specification, and there are distinct design phase. That is, we have standard design techniques which are being employed. And during all these stages of development process, there are reviews, periodic reviews, timely reviews that are being carried out. Testing has become more systematic, more planned, more thoughtful and managed. And number of these testing techniques are available to us. There is better visibility of design and code. What do we mean by this? By visibility we mean that we produce good quality, consistent and standard documents. But in the earlier times, very little attention was given to producing good quality and consistent documents. There were no quality checking or not a single document either. We will see that this increased visibility makes our software project management and maintenance thereon quite easier. And if we have good documentation, we have this diagnosis of any problem, fault, bug and maintenance. They are quite easier now, smoother now. Various metrics are there. We call them metrics because they measure something, they evaluate something. So they help software project management and quality assurance and various aspects and parts to be evaluated more precisely. Projects are now thoroughly planned. Previously, we were not aware about the time or the scheduling, it was not there. Now we have various monitoring mechanisms. And finally, using this case tools, computer assisted or aided software engineering tools. What about our software lifecycle? What is a software lifecycle or software processes? The series of identifiable stages that a software product undergoes during its lifetime. So if this is a software, say life, then we divide it. Then we identify these stages, and these are number of stages: 1, 2, 3, 4, and these stages are thought, documented, planned, and here inception of software takes place till the time the maintenance or software dies or it meets its end. This is the life cycle of a software. We start with feasibility study, then requirements analysis and design, then we have design, then we have coding, and then testing, and finally to maintenance. This is the part where maintenance goes. So software lifecycle model or a process model, it is actually a descriptive and diagrammatic model of a software lifecycle, and it tries to identify all the activities which are required for our product or software product development. And also it lays down the precedence ordering, which order which activity should come, and it divides the life cycle into various phases as we have just seen. So several different activities may be carried out in each life cycle phases. The life cycle or the phase of a life cycle is a bigger picture. Various different activities may concurrently go on. I'm not saying different stages may go on, because there are various life cycle models where various stages can also they can run concurrently. Well, let me give you an example. The design stage might consist of your structure analysis activity, which may be followed by our structured design activity. So why we require, or we are talking about model life cycle? Because we need a written description which forms a common understanding of activities among software developers and the users. And they helps in identifying inconsistencies, any problem, redundancy, any omission, any problem, any loopholes in the development process. And they help in tailoring, means mending or melting a process model for specific projects. These processes are tailored, that means they are not specific, but they can be amended for special projects. A document process model, this helps to identify where the tailoring is to be done. And the development team must identify a suitable life cycle. As I indicated, there are various life cycle models which are being proposed and used heavily. First, you have to choose, and then you need to adhere to it. What is the advantages of adhering or keeping on with some lifecycle model? It helps in development of software in a systematic and disciplined manner, which we really want. So when a program is developed by a single programmer, he can decide, he has a freedom or he has a luxury to decide his exact steps. But when the software product is developed by a team, then there has to be a very minute and precise understanding among the team members as to when to do what. Otherwise, there will be a chaos or a failure. A software project is never going to succeed if one person or one engineer starts writing its own code in different manner, in his own style, without worrying about the life cycle. Another concentrates on writing the test document first. He says, no, I'll write this test document. This is my job, I'll do it first. Another engineer, he defines the file structure. He is busy in doing this work. The other one says, let me define the input output for my portion. So this is not going to work. A lifecycle model, it defines exact entry and exit criteria of every phase. There are certain deliverables, and the phase is considered to be complete only if all its exit criteria, these criteria, are being satisfied. Since this exit criteria for your software requirement specification phase, just for instance, SRS document is complete. They are reviewed and approved by the end user or the customer for whom the software is being made. This phase can start only if the phase entry criteria has been satisfied. Now it becomes quite easy for these managers which manage this software project to monitor the progress of the project now. And when this life cycle model is stick to or adhered to, this PM, a project manager, can at any time fairly accurately tell that at which point, which stage, say design, code, test of the project we are. Otherwise, it becomes very difficult or ambiguous to track the progress of the project. The PM would have to depend on the guesses of the team members. He'll ask some wild guess will come, and he will explain it to the superiors or to the customers. So what problem can occur? This is known as 99% complete syndrome, which is the problem which comes from this particular instance or scenario. This is known as 99% complete syndrome. So many life cycle models are and were proposed. We'll try to focus our attention to some of the classy and commonly used employed model. First, we have classical waterfall model, iterative, evolutionary, prototyping, spiral. And now we have various models for fast forward production. We'll discuss about them also. So in summary, software engineering is a systematic collection of decades of programming experience along with the innovations which are made by researchers. And the fundamental necessity to develop a large product or large software product is to adopt a lifecycle model and adhere to this software lifecycle model, which gives rise to or helps to do various development activities in a systematic and disciplined manner, and also make it easier to manage a software development effort. So this was about the various stages and the life cycle model and how these things evolved and how it can help in a better software development. Thank you so much. Take care.